Welcome to Easy BTech. So the next concept name is we have discussed in the previous class about the types of random variables and their distribution and density functions. Now we will see the next concept, that is operations on random variables. So the concept name is operations on 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 one random variable. One random variable. Operations on one random variable. So the first concept name is expectation. Very important one. The first concept name is expectation. Expectation. So, so what is meant by expectation? So the process of averaging, the process of the name given to the process of averaging averaging when a random variable is involved is called is called expectation is called expectation. So expectation is nothing but one type of averaging, but if the random variable is involved, it is called expectation. So the name difference is here. Average means averaging a random variable is called expectation. So it is represented by like this. So the expectation e of x. Suppose in any problem they gave you e of x, means they are expecting us to calculate expectation of that random variable inside x. Or this is also represented sometimes like x bar also, x bar also, x bar also. Or it is the expressions in the words they will ask you sometimes mean value of random variable. In sometimes they will ask you mean value of x, mean value of x. So whatever may be the word they are using, you should find out the expectation. So from this we can write x bar is equal to expectation of expectation of. So now we will see the formula for expectation. The formula for expectation is like this. So the expectation formula is expectation of x is equal to integral of minus infinity to infinity. So whatever may be the inside function, that you should write with small x into f x of x dx dx. So this is the expression to find out the mean value or average value or expectation or x bar, whatever may be the sentence. So the this is the one we have to calculate. So a mathematical integration you should do to find out the expectation when a random variable x is involved. That means, so the formula is integral minus into infinity x into fx of x dx, where where fx of x is what we already know. Fx of x is the density function of random variable. Density function. Fx of x is called density function of of given random variable. Given random variable. Fx of x is the density function of the given random variable. So if you see the properties of expectation, the properties of next name is properties of expectation. Properties of expectation. So the properties are we can write like this. So the first property is expectation of ax is equal to a into expectation of x. Expectation of a is equal to a into expectation of x. So why? Because see, expectation of x formula we already know. How will write? We'll write integral minus into infinity x into fx of x dx, fx of x dx. So this is the expression for expectation of x. So what they ask you is expectation of ax. So you just replace whatever may be the value inside the expectation. That means here you are having what? You are having ax. So whatever may be the value, you should just write that value ax into fx of x dx, fx of x dx. Now what I will do, I will take out the a common. I will take out the a, y it is a constant. So x into fx of x dx, which is equal to a into expectation of x. That means what we conclude from here is if you multiply random variable with x, a random variable with x, then it gives you what? It gives you what? So the take out the constant. I mean a random variable with a constant a. It takes out that a value to the outside, multiplied by that individual expectation of x. So this is the first property of random variable. Next property, expectation of a constant a. Expectation of constant a is always equal to a. How? We'll prove this one. So we take expectation of x formula, we already know. Just take expectation of a is equal to, that means you should replace that a with what? So that x with what? A. That becomes, sorry, a fx of x dx. So since a is constant, I will take a to the left side. I will take a common, integral minus into infinity fx of x dx. So from here we will say that it is equal to 1. It is equal to 1. Why? Because we already know that from the properties of density function, it is always is equal to 1. So we can say that the constant is equal to 1. That means, for example, expectation of 1 is equal to 1, expectation of 2 is equal to 1, expectation of 2 is equal to 2. So whatever may be the constant inside, so same is reflected as the output. Same is reflected as the output. Is the second property of expectation. Now moving on to the third property. So the third property is like this. So the third property, expectation of ax plus by. Expectation of ax plus by can be written as a into expectation of x plus b into expectation of y. Expectation of ax plus b, ax plus by is equal to expectation of ax, expectation a into expectation of x, b into expectation of y. Or else we can write this one is like this, expectation of ax plus b equal to what we, how will you write? Expectation of ax into, sorry, a into expectation of x plus b. So this is the third property. We are combining both the ones. I mean first property and second property both are combined here. That gives you this one. That gives you this one. So these are the three properties of expectation. So we'll see the problems of expectation now. So if you extend these properties to another one, it is also like this. Expectation of ax square plus bx plus c. If they want you like that, then it becomes a into expectation of x square plus b into expectation of x plus c. So these are the different types of properties of your expectation. So four properties. So expectation of ax is equal to a into expectation of x. Expectation of constant is equal to constant. Then expectation of ax plus b is equal to a into expectation of x plus b. And expectation of ax square plus bx plus c equal to a into e of x square plus b into expectation of x plus c. These are the four properties. Now we'll see one problem on expectations. So what I am expecting is, so the problem is first problem. So find e of x, that means expectation, or in some case they gave you x bar for exponential random variable. Exponential random variable. Now see, here they gave in the problem they don't give you density function. They don't give you density function. So this is the importance of your density functions in the um, previous sessions. So while doing the problems they don't give you density function. You should remember the density function of exponential function, and you have to substitute that one is here. So if the in the problem if they gave you density function there is no problem, but in some cases they don't give you this one. So that's why you have to remember every density function of every random variable. Now see, so we already know that expectation of x is equal to integral minus into infinity x into fx of x dx. Now what I have to do is I have to know the density function of exponential random variable. So density function of exponential random variable is given by 1 by b into e power minus of x minus a by b for x greater than or equal to a. Now see, this main condition gives you the limits of your expectation. So if you place the limits there, as the value of x starts from a, so the limits expression is 1 a to infinity and into x and substitute your density function, so that becomes 1 by b e power minus x minus a divided by b into dx, x minus a by b into dx. Now I am moving on to the integration, so which is equal to so I will take out 1 by b common, integral a to infinity 1 by b e power minus, sorry, not 1 by b, x into e power minus x minus a by b dx. Now I have to do this integration. What I will do is, so I will take out, I will do this one, UV rule. UV rule. So first function into integration of second function. So the first function is x into, or else I will do one thing. So what I will do is I will take x minus b by a by b is equal to k, some k. So if you place then what are the variables of k? If you plate x equal to a, that is k equal to a minus a by b, k equal to 0. If you plate x equal to infinity, that equal to k equal to infinity, and I will write x equal to bk plus a, bk plus a, and I will write dx is equal to b into dk. So these are the everything we are supposed to substitute in an above expression. So after the substitution, what I will get is 1 by b into, so the integral limits are 0 to infinity. In place of x, what I will write? I will write b k plus a, bk plus a into e power minus k. In place of dx, what I will write? B into dk. b b get cancelled. b get cancelled. So I will do integration now, which is equal to integral 0 to infinity, I will rearrange this equation to b into e power minus k dk plus integral 0 to infinity e power minus k dk. So I will do integration now. So which is equal to b into first function into integration of second function. So first function is k into e power minus k by minus 1 minus differentiation of first function is 1, integration of second function is e power minus k. e power minus k by minus 1 dk. So plus a into e power minus k by minus 1 minus k by minus 1. So afterwards, which is equal to b into minus k e power minus k, and after the differentiation integration what I will get is e power minus k minus e power minus k ranges from 0 to infinity, and here it is ranges from, so I will take out e power minus k. If I write, if you remove that minus, I will write minus sign here, and it is from 0 to infinity. So what I will do here, I am just doing integration. So first function into integration of second function. So first function is k. The integration of e power minus k equal to e power minus k by minus 1 plus integration of differentiation of first function means my k value differentiation is equal to 1. That's why I didn't write here. Into integration of second function is e power minus k by minus 1. So this minus and this minus and I will make 1 and is equal to integral. So again I will do integral, it becomes e power minus k by minus 1. So I will take out minus sign here and I am applying integral limits here. So in the same way this one also. So now I will apply integral limits. So which is equal to, if you apply infinity here, the upper limit which gives you, this becomes 0 and this also becomes 0. Why? Because infinity, e power minus infinity is equal to 0, e power minus infinity is equal to 0. Similarly, if you place lower limit, it becomes what? So upper limit 0 minus of lower limit. If you place lower limit, so minus of 0. So that means 0 minus lower limit means if you place 0 e power 0, it becomes 1. That it is like this, minus a into here also 0 minus 1. So finally I'll get minus into minus plus 1, 1 into b, so b plus a minus a into minus 1 a. So finally I will get a plus b for the expectation of exponential random variable. In this way, we will find out the exponential of any expectation of any random variable. What is the process is, you just need to substitute the density function in the given expression, given expectation formula, 1 by b into e power minus x minus a by b into dx. So everyone may follow their own integration strategy. I will follow this one, or else you can take directly this one, k into not k, x into e power minus x minus a by b directly, and you will get what? Finally, the value should be a plus b. So in this way, you can find out the value of any random variable expression, whatever may be the given function. Given function. So what I will take is, I will take x minus a by b is equal to k. X minus a by b is equal to k. That means we have to find out the that means limits of your k. That means if you place x equal 0 here, so k, sorry, x equal to a here. Why? Because the lower limit of x is always equal to a. That means a here, a minus a by b. That means k equal to 0. Similarly, if you put x equal to infinity in this expression, infinity minus a by b, and that gives you k equal to infinity. So finally, it becomes x equal to, then if you write what I will write, x equal to b, I will take out the cross multiplication, x equal to bk plus a, and for that this variable dx, I will take out the differentiation on both sides, dx is equal to, I will take b on the right side, it becomes bx b into dk, and I will substitute all this in this expression. It becomes 1 by b integral 0 to infinity bk plus a into e power minus k b into dk, and this b get cancelled and cancel. then I will be only left with bk plus a into e power minus k, e power minus k. So what I will do is I will split this expression into two integrals, that is I will take out b into integral 0 to infinity k into e power minus k dk plus integral 0 to infinity a into integral 0 to infinity e power minus k dk. So next one is so take the UV rule of integration. So first function into integration of second function minus differentiation of first function into integration of second function. That is the UV rule. So b into, take brackets open. First function is k according to Euler rule, k into e power minus k by minus 1 and what I will write here is actually it is minus sign. So minus n minus of, it is also minus sign, integral of differentiation of first function is equal to 1 e power minus k by minus 1. So that's why I write this and this one as plus 1. Why? Because minus into minus plus 1 into dk plus a into integral of expectation e power minus k by minus 1. So here it is 0 to infinity, upper limit and lower limit. So again there is one more integration left. I will take the integration this one. So minus sign as it is, minus k e power minus k. And how come this minus sign comes? Because again you are doing integration of e power minus k. So there comes one minus sign in the denominator. I will take out minus sign like this. So it becomes e power minus k of 0 to infinity minus. Where come this minus sign come? Because of this one. So I will take minus sign here. A into e power minus k ranges from 0 to infinity. Now substitute upper limit and lower limit. So if you put infinity in this expression, see here, infinity into e power minus infinity. Actually e power minus infinity is value is always equal to 0. That's why it is 0. Minus of again e power minus infinity. So that's why 0. So upper limit minus, now lower limit. So lower limit means 0. So 0 into something, whatever it may be. So that's why it is 0 minus 0. I mean here you have to apply 0, e power minus 0. So that's why it is equal to 1. So limits applied for the first integral minus. I will similarly apply integral limits 0 to infinity. So e power minus infinity is always equal to 0 minus of. So apply lower limit, e power minus 0 is equal to 1. So after rearranging this equation, I will get the value of b plus a. So I can write the expectation of exponential random variable is equal to what? A plus b. A plus b. So now this is in case of continuous random variable. Suppose they gave you discrete random variable. So and find out the expectation. So in this case, we should see this one. So the discrete random variable expectation formula is given by expectation of x equal to integral I equal to 1 to n xi p of xi, where p of xi is the probability of a random variable x at an instant I. So this probability is always less than or equal to 1. So and this value of n is always depends on the number of random variables. So now we'll do one problem on discrete random variable. See, suppose the problem is like this. Given xi equal to I square, xi is equal to I square, where I ranges from 1 to 5. 1, 2, 3, 4, 5. And the probabilities at given instance, that means I equal to 1, it has a probability of 0 0.4, 0 0.25, 0 0.15, 0 0.1, 0 0.1. So this is the problem they gave you. So what they want us to find is expectation of x. So how to find the expectation? So before doing the expectation, see this. Thus the problem is like this. So if you observe this all probabilities together. So 0 0.4 plus 0 0.25 plus 0 0.15 plus 0 0.1 plus 0 0.1 is always equal to 1. Is always equal to 1. So suppose they gave you empty, I mean they gave you one of the variable here, that means 0.15. They don't give you, they gave you a variable, suppose a. So find the constant a, like that they will give you. In that case what you have to do is add these all the properties and make them is equal to n, and you can find out the constant a here. Constant a here. In this way, you have to find out the constant. Now see, I will according to given formula expectation of x equal to integral I equal to 1 to 5. Why it is 5? Because the I value is only ranges from 1 to 5. That's why I equal to 1 to 5. Xi p of xi. Xi p of xi. So what I will do, I will expand this expansion. So xi equal to I square p of xi. So 1 square p of x1 plus 2 square p of x2 plus 3 square p of x3 plus 4 square p of x4 plus 5 square p of x5. So I will substitute these values of probabilities here. 1 into 0.4 plus 4 into 0.25. Why? Because they gave you probabilities here 0.4, 0.25, 0.15, zero point 0.1 and zero point 0.1 respectively. So these respectively means these are the probabilities at that values 1, x1, x2, x3, x4, x5. So x5, p of x5 has a probability of 0.1. P of x4 has a probability of 0.1, P of x3 has a probability of 0.15 like this. So that's why I am substituting these probabilities here. Then in that case it becomes 1 into 0.4 plus 2 square means 4 into 0.25 plus 3 square means 9 into 0.15 plus 16 into 0.1 and 5 square 25 into 0.1. So I will add all of them 0.4 plus 1. Why? Because 0.25 into 4 1 plus 0.15 into 1 9 1.35 1.6 2.5. If you add all these together, so 0.4 plus 1 1.4 plus 1.35 2.75 plus 1.6 4.35 plus 2.5, that is 6.85. So this is the expectation of the given discrete random variable. Discrete random variable. Now moving on to the next thing. So the next concept name is expectation of a function of a random variable. Function of a random variable. As the name indicates, function of a random variable. That means you are expressing your random variable in terms of a function. The function. In this case, I am assuming my function is like this: g of x. G of x. So if you are assuming your function is g of x, then what will you gives you is expectation of g of x is equal to what? Is equal to what? Equal minus into infinity g of x into fx of x dx. The only blind rule you should remember is whatever may be the inside the exponent expectation, that the same thing should substitute in this integral by replacing a capital X with the small x and do the integral as it is. There is no change whenever you are getting expectation in everywhere in your probability. So just remember the inside function. So the inside function should be substituted inside the integral by replacing capital X with the small x. So this is called the expectation of a function of a random variable. Expectation of function. Suppose they gave you here. Suppose they gave you here expectation g of x equal to x square. G of x equal to x square. They gave you like this. That means the function they represented is g of x equal to capital X square. Then what is the expectation of a function of a random variable? That means you should take g of x like this, and what you should do, integral minus infinity z, you can substitute small x square here, and you can take out the fx of x as it is, fx of x as it is. And after substituting the given density function in this integral, this final value is called the expectation of a function of a random variable. In this way, suppose in this, if you take for timing, if you take this one, what is this one, uniform random variable, then it becomes x square into the density function is 1 by b minus a dx. 1 by b minus a dx. So why? Because I am assuming x is uniform random variable. Uniform random variable. So for uniform random variable, density function is 1 by b minus a. Then I will do integral like this. I will take out the 1 by b minus a common, by b and a are constants. The integral is x cube by 3 and ranges from a to b. If you substitute integral, then it becomes 1 by b minus a b cube minus a cube divided by 3, upper limit minus lower limit divided by 3. And what I will do is next is 1 by b minus a. I will apply a cube minus b cube formula, then it becomes b minus a into b square plus ab plus a square divided by 3. Both are get cancelled, and finally I will get the value of b square plus ab plus a square by b, and it is expectation of g of x, this one, expectation of g of x. In this way you have to find out the function of a random variable, function of a random variable. So with this I'll conclude this session. So welcome all of you, please subscribe to Easy BTech channel.